Good morning. Welcome to the webinar on running Microsoft SQL Server on Google Cloud Platform. My name is Amrita Galanikar. I'm a product manager on the Google Cloud Platform. And in the next half an hour, we're going to talk about how Google Platform is best suited for running your Windows and SQL Server workloads. So here's a quick recap of what we're going to be covering in the next 30 minutes today. We're going to talk about why you should bring Windows workloads to Google Cloud Platform, what support we have for SQL, the best way to get the best performance out of your SQL VMs. In the end, we will have a quick demo and also have time for Q&A. So let's get started. So Google Cloud Platform has been supporting Windows Server images since 2015. We first started with Windows Server 2012 and 2008, and over the last year, we have had about a dozen or more launches and improvements specifically for Windows and SQL Server. So in March, we GA'd SQL Server images. So these are pre-configured images with license included. We had a lot of support for cloud tools on .NET, Visual Studios. If you have run ASP.NET Core apps, we have support for that in App Engine and GKE. And for your critical enterprise workloads, we also release features like VSS, integrated snapshots, support for WinRM, and also all the clustering methods that you're familiar with on-premise. So a lot of customers ask, why run Windows on Google Cloud? Well, first and foremost, when you decide to run your Windows applications on Google Cloud, you're running on Google's infrastructure, the same infrastructure that Google runs on. So your traffic never leaves the private fiber network of Google, even between data centers. You get amazing speed. So you get really good VM boot up times, you get really good and consistent latencies, and we can basically scale. Auto-scaling just works. So along with all the inherent platform benefits and inherent network benefits, there are also certain advancements in the platform specifically for Windows and SQL Server that I want to call out. So we have support for key Windows features like Windows Server clustering, all your SQL Server clustering, VSS integrated PD snapshots. You can not only see the output of the interactive serial console, but you can also interact with it. So this is really handy in debugging issues with your Windows VMs. So let's say your Windows VM lost network connectivity, you can connect to the SAC, kind of see if the Windows firewall is working, reconfigure it, and you're up and running. The second pillar that I kind of want to focus on is developer tooling. So if you're a .NET developer, you have support for .NET tools for Visual Studios, for PowerShell, for PowerShell as well as Visual Studios. Our Cloud Client libraries in NuGet are a great resource. And as I said earlier, ASP.NET Core is supported both on App Engine Flex as well as in GKE. Flexibility is another reason why customers like to bring their Windows workloads to Google Cloud. Custom VMs are great. You don't have to go in predefined standard in shapes or machine shapes. You can actually pick and choose what number of vCPUs and how much memory you need to make sure that your workload can run well on that VM. And this is really critical for Windows workloads because your licensing costs are actually tied to your CPUs, the number of CPUs that you run. So you can basically say, I can run a 4-core CPU with extended memory if that works well for your workload. So a lot of options and a lot of flexibility. Now coming over to SQL Server and focusing, next few slides will focus primarily on SQL Server. So in March, during GCP Next, we went live and GA with our SQL Server Enterprise Standard and Web images. So you can basically take a pre-configured image and spin up a SQL Server instance on Google Cloud Platform in a matter of minutes. As you can see, we have a number of editions as well as versions supported, and 2017 coming soon. And these images basically have Windows Server and SQL Server pre-installed. So when you spin up an instance, you pay for the usage as well as the licenses for Windows and SQL Server included in that. So two questions I always get whenever we kind of talk about Windows and SQL Server workloads is licensing and pricing. So let's address that first. In terms of licensing for SQL Server, you have two options. First, you can bring your own SQL Server licenses. So if you have an EA and if you have bought your licenses for the next 2 or 3 years, and you want to reuse some of them, if you have software assurance, you have the ability to move those licenses to a cloud. So make sure that you have software assurance and have the license verification, and you can move them to GCP. The second option, which a lot of customers find very convenient, is that you don't really have to bother about licenses. Use the pre-configured images, and you pay for licenses as well as usage as much as you use the VM. So if you spin up the VM for 1 hour, you will be charged for 1 hour worth of licenses as well as usage. So this is really convenient. Another thing to note is our images are updated every month. So all the new updates and patches and security updates are kind of rolled up into these monthly updates. So that way you kind of get the convenience of not only having the most up-to-date images, but also licenses included in them. Pricing, as I mentioned, and you probably heard the announcements, we make sure that, we are price performance competitive. We have a per second billing for your Windows Server VMs with a 1 minute minimum. If you go to the link below, which is cloud.google.com/SQL Server, you will see the pricing for SQL Server VMs based on each SKU. One thing I really like to kind of call out is our Windows and SQL Server images are available in the free trial or the trial at no cost, and you have $300 in credit. So it's a really great opportunity to go and try out SQL Server VMs and kind of give them a spin. If you are running SQL Server workloads, one of the questions I get is most of these workloads are steady state. So you're running the SQL Server databases 24/7. In that case, you will definitely get your sustained use discount, which kicks in automatically up to 30%. You don't have to do anything. However, you can get additional discounts on your base VMs by opting for the committed use discount. So highly encourage you to kind of consider if you want a 1 or 3 year commitment for more discounts, and that makes it a really a price-efficient option on Google Cloud Platform. Cool. So now let's kind of talk about some of the key things that customers think about when they actually want to move to the Google Cloud Platform. So you have a SQL Server database. You definitely have a mission-critical application running on it. You care deeply about reliability and availability. So on Google Compute Engine, we support different configurations for high availability. So SQL Server as a product introduced always-on availability groups in 2012. Prior to that, they had always-on failover cluster instances. We support both those configuration types. So if you're familiar with those on-premise, you can actually build those very same configurations in your GCP project on the cloud. Now, in addition to these clustering methods, which are natively supported by SQL Server and also supported on GCE, you can also use your traditional methods such as log shipping or transaction replication or DB mirroring. So let's go into a little bit more detail into each one of these configurations. So the first one and a highly recommended one for the SQL Server team is the always-on availability groups. This was introduced in SQL Server 2012, and we now support that configuration on Google Cloud. One of the things I kind of wanted to go around is not only just show you that it is supported, and the diagram over there gives you a quick overview of what the architecture looks like, but I'm also going to walk you through some of the common questions on this configuration. So as the diagram shows you, you have a 2-node cluster. These are 2 SQL Server nodes, and they are a part of the same SQL Server always-on availability group. Underlying, you can define these nodes in the same region in 2 different zones, or in 2 different regions in 2 different zones. So what we have over here is a regionally high available configuration. The thing to note over here is it's key that this is a multi-site failover cluster. So if you notice closely, if you can see in the diagram, each node is in its own subnet, right? And that is kind of critical because the configuration that we're supporting is a multi-site failover cluster. The second thing to kind of note about this is that when you have a SQL client which is connecting to this, make sure that it has the multi-subnet failover option selected. So those are kind of 2 key things to kind of note when you think about this configuration. The other one is about how you actually allocate these cluster IPs. So we know about the static IPs, right? So when you create a SQL node, make sure you assign an internal static IP. But in addition to that, every node will have a cluster IP and a listener IP. So this is a quick diagram to just show you what that looks like. So we set up, in order to make sure that the failover, once the failover happens, GCE directs the traffic to the right node, which is primary at that point. We have a bunch of GCE advanced routing rules that are set up. So as you can notice, you have two different subnets, WSFC subnet 1, WSFC subnet 2. You have the two nodes with an internal IP in this subnet range. And if you notice that the subnet masks for the subnet and the VM are slightly different. So the VM subnet, which is a /16 network, is a superset of the subnetwork. So that gives us an opportunity to select a listener IP which is outside the subnet 1, but inside the VM subnet. I always like to kind of map out all my listener IPs and my internal IPs before I get into this configuration. But if you want to give it a try, and I'll show you in a quick second when we do the demo, we have a Cloud Launcher solution. Cloud Launcher is our marketplace, and you can deploy this configuration in one click. So if you just want to kind of go and see, okay, how does it work, how the route's set up, compare it with what you have a one-click deployment option available for this configuration too. So we talked a lot about the always-on availability groups. We talked about some of the key things to remember when you're configuring them. Let's go to the other option. So the second option that customers want supported for SQL Server is always-on failover cluster instances. Now this was generally supported in 2008, SQL Server 2008. It's also a popular method for the newer versions of SQL Server. And we support that in two different ways. So along with sort of launching support for SQL Server and SQL Server images in March, we also launched support for the Windows Partner Program. Now, this partner program ensures that we have a great set of system integrators and ISVs who specialize in Windows and GCE certified on our platform. So SIOS DataKeeper is a Windows partner. They have certified their solution on the Google Cloud. And SIOS DataKeeper is a great option for customers who want to set up a SQL Server failover cluster using either SQL Server 2008 or even SQL Server Standard. So as you can see in the diagram over here, the SIOS DataKeeper kind of allows you to kind of specify your cluster and sort of manages the replication between the two database servers without actually needing a SAN. So that's kind of one option. The standard option is great because it does not support as many high availability features as the enterprise. And it's also a cost-effective way. So definitely encourage you to kind of go and look at the solution. The second way is SQL Server failover cluster using storage direct spaces. So Windows Server 2016 introduced storage space direct. And it's a way in which you can actually cluster all the storage that is associated with any node in the cluster. So as you can see in the diagram over there, you have two SQL nodes. Each one of them have some storage attached to it. And what storage direct spaces allows you to do is sort of cluster that and expose that as a single clustered volume. And you can store your database on this single clustered volume. So that kind of allows you to kind of replicate like a virtual SAN to mimic maybe your physical SAN, which is on-premise. We're very kind of happy to kind of make sure that this feature was in Windows Server 2016. And currently we have this configuration being tested by a couple of customers in an alpha. So if you're interested in sort of trying this out in the alpha, please reach out to me. So we go into a couple of more options. When you kind of think about databases, you want to think about storage. We have persistent disk. We have two different types of persistent disk. And we have also local disk, which is extremely high performance block storage, but it's not persistent. You can, in this slide, kind of note the difference between a standard PD and a SSD PD. You can, as you can see, the SSD PD has 40K IOPS. So this is really a great option if you want really high throughput and bandwidth on your SQL Server VMs. So our recommendation for storage options is that you actually use PDSSD for your data disks, and for things like your cache or your page file to go for local SSD. The two guides there are great options if you want to learn more and get more details. Similarly, for backup in DR, we have a bunch of different options. You could definitely use the native SQL Server backups, or you could always kind of back up your database to a Google storage bucket, or you can take snapshots of your data disk using the VSS-enabled snapshotting. There are multiple options, and it all depends on sort of what kind of recovery time are you looking for, and kind of what option meets your needs. So there is another detailed guide which I highly recommend that you actually go through, and send us questions if those guides don't have the details that you kind of need. So we've got a lot about the different configuration methods, the images supported. So let's dive and actually look at this stuff. So I'm going to switch over to my demo machine. So this is Google Cloud Console. I'm going to really quickly show you how easy it is to create a VM. So I have a VM over here that I've just created. This is a SQL Server instance. We'll look at it in just a minute. But if you just go to Create Instance up there, you'll see like this nice instance creation page, and you'll have the option to select your boot disk. Now this is where you select the image that you want the instance to be spun up with. So if you click on Application Images, you see a wide array of SQL Server images available to you. So you just need to click on the one that you want. Let's say I take 2016 standard. You kind of select the right machine type. In my case, I want to do a 4 vCPU machine. Note you can always customize this, so you can basically see if you want extended memory or not, or you want maybe 2 CPUs with extended memory. And then just say yes, create. So in this case, I'm just going with a very simple thing, and there you have it. So while this kind of creates, which takes a few minutes, let me just show you. You can, from your Chrome browser, without leaving anything, RDP into the machine. So really quickly, there you go. You're able to log into the machine. I have just brought up the SQL Server Management Studio, and you can run a few queries. It's that simple. So going on to kind of the next thing is, the next thing I wanted to show you is, let's see if clustering can work. So remember I told you like the clustering feature for FCI is sort of in preview. So what we've gone ahead and done is we've sort of set that up. So these are 2 nodes. These are your SQL nodes, which are configured in a failover cluster instance. We have a domain controller to kind of define what your Windows domain is. And then we have set up a simple client machine. So what we're going to test now, or what we're going to try to see if this demo works, fingers crossed, we're praying to the demo gods that all of this works, is right now both of these nodes are working. They're in a SQL failover cluster, as I said. Now what we're going to do is we're going to try to log in to one of these VMs, see which node is primary in the cluster, and then try to mimic a failover, right? So we're going to try to reset one of those VMs, see if that, see that VM goes down, and see if the next VM actually comes up as the primary. So let's give that a spin. So what I've done over here is I have used remote desktop and kind of logged into the SQL client VM that I'd shown you earlier. And I have a really simple query. I'm going to re-execute it. And this basically queries, hey, what are the nodes in the cluster? Tell me which one is a primary. So if you look at the table below, you will see like the node 07 is the primary, and the other one, 9B, is a backup. So this is running great. What I've also done is I've created like this test table over here. The table is really simple. It just has a few rows in it. And all that I'm going to do is try to display what those rows are. So it's a very simple query. I have this query running over here. It's just doing nothing but querying that table. So great. So we have all of this working. I'm going to go back to my demo machine. And this was the primary, right? So I'm going to basically say, let's say there's a hardware failure, right? So we can kind of replicate that by just resetting this VM. So what we expect is that this VM now goes down, is no longer the primary, and the other VM, which is the node 9B, comes up as the primary. So let's see if that works. So here we go. So if you kind of see the query that I was running, you'll kind of see it stopped, right? And this is because the failover has happened. And it'll take a few seconds, hopefully less than 30 seconds, to kind of come back up. So let's kind of execute that again to see, hey, is my cluster up? What is the primary in that cluster? So once it has failed over, it will actually come up as the primary. And what we are expecting to see is both nodes up, but one of them will be the primary, which was earlier the secondary. So as you can see, in 17 seconds, we've had the failover. We have node 9B which takes over as the primary now. And we can kind of see that the node 07, which was earlier the primary, is now down. So you can kind of look at the status. Now let's see if that query is back up again. So let's try to execute that query. And yeah, I can continue querying my table. So in less than 30 seconds, there was like a major hardware reset, a node completely went down, and now you're back up and running. So this is kind of just to kind of demonstrate to you how the failover will work in a GCP project really easily. Cool. The last thing I wanted to show you is configuring SQL Server always on can be really complicated and tedious. And sometimes, there are steps you kind of want to understand how the network is actually configured. So we have this, Cloud Launcher, which is our marketplace tool. And I'm going to show you really quickly. So if you search for SQL Server HA, you will get this really nice template. And this template basically will deploy a 2-node cluster for you in your project. So if I kind of just click on Launch on Compute Engine, it will basically allow me, I have some Coda issues over there, but I'll kind of take care of that. It'll allow me to kind of specify where I want my SQL node. So it'll allow you to pick a zone. It'll allow you to specify a domain for your Active Directory. And the domain basically defines the Windows domain in which the 2 clusters will be there. It'll also allow you to pick what your SQL configuration should be, what kind of VMs do you want there, select the storage you want to add to it, and go. So I'm not going to deploy it over here because you kind of just saw a quick demo of that. But this is a really easy way to kind of get started, deploy it, and then kind of test it out if it works, and then kind of re-replicate that based on your network and your throughput requirements for SQL Server. So that's kind of a quick overview of the different things that we support for SQL Server on the platform. And one more thing that I wanted to kind of show you as we kind of go is, as we come back, is when we kind of looked at the storage options, another important thing to kind of note is the SSD and the PD. Let me really quickly show you how you can actually create that. So if I go back to my Compute Engine instance, and let's say Create Instance, in your Create Instance pane, and by the way, you can do this through the Cloud Console, which is our UI, or you could do this through gcloud, which is our command line interface. To show you really quickly, you can bring up the command line interface right here. So in your browser, we have the product called Cloud Shell, which brings up the Google Cloud CLI, and you can create an instance using your gcloud there and there. So what I wanted to show you is when you're creating an instance, you can basically specify what data disks you want attached to it. So typically, you will have your system configured on the boot disk, which is the main system disk, but you want your database typically not to rely on that. You want it on different data disks. So this is a great way in which you can basically just add a disk. You can specify if you want to keep the disk once it's deleted. You can select an existing disk, or you can create a new one. So in this case, you can create a new disk. Note, you will be told kind of what the limits are. So earlier, I kind of showed you whether you should use PD SSD or you should use a standard SSD. And this really gives you a good idea of, the cost versus the IOPS you're getting on each one of these options. So if you get a standard persistent disk, these are the sustained IOPS. As you can see, if you jump that to a SSD, you get a much higher IOPS on this. So this is a highly recommended option every time you want to consider a SQL Server database. So cool, so we've given you guys a quick tour of the platform. We have shared with you how you can create a SQL server, how you can add storage to it, what are the options for backups, what are the options for high availability, and what are some of the tips and tricks when we're configuring these configurations. So with that, we'll have a short break and be back for questions in some time. So welcome back. We're going to take a few questions from the audience. The first question is, can the SQL Server nodes in an HA cluster for always-on availability groups be available in different regions? The answer is yes. You can define your SQL nodes in the same region in two different zones, or in zones which are in different regions. A lot of customers can also define two nodes which are in the same region and a third read replica which is in a different region. So in case there's a regional failure, you can always back up to your DR copy too. So yes, those options are possible. Cool. Moving on to the second question. Can the SQL Server node in a high availability cluster for failover instances be in different regions? So it depends on if you're using, the answer kind of depends. So if you're using the SQL Server failover cluster using the SIOS data keeper, then yes, you can do that. However, if you're using storage space direct, the feature that we sort of have in an alpha preview, we kind of depend on, the way we kind of do that clustering depends upon the internal load balancer. So we need to kind of set up an internal load balancer between those nodes. And currently our internal load balancer is regional. So you'll have to kind of define the nodes in a particular region. So you kind of have two options. If you need it to be in different regions, then I would say go with the SIOS data keeper option for your failover cluster instances. Now, if you're doing the HA with always-on availability groups, then yes, that is a completely multi-region configuration that we can support. Going on to the third question. Do CUDs and SUDs apply to SQL Server licenses? Now, that is a great question. Currently, CUDs and SUDs apply to the base VMs. So as I mentioned earlier to you, when you kind of look at your bill, you will see a line item for the base usage VM, then you will see Windows Server licenses and the SQL Server licenses. So currently, all our CUDs and SUDs apply to the base VM. We will have some improvements coming in next year, and more products and more options that get added to the CUDs. But for right now, they're only applied to the base VM. Cool. Moving on. The next question is, do you plan to support SQL Server 2017 on Windows and Linux? Yes, we definitely, one of our key goals is to make sure that the latest innovation that is available on Windows Server and SQL Server is available to all our customers as soon as possible. We work very closely with the SQL Server team at Microsoft, and we're making sure that they go through the due diligence and validation on our platform, and we're very close to supporting SQL Server 2017, both on Windows and Linux. So you will see some more updates and announcements coming in the next few quarters around how you can actually run this on either Windows Server 2016 or on a Linux machine. Cool. Next question. So that was a really good question. The next question is also a really nice one. So do you plan to support managed offering for SQL Server? Now, we get this question quite a bit. The offering that we currently have is a self-managed offering for SQL Server. We have a product called our Cloud SQL, which is a managed database offering. Currently, that supports MySQL and Postgres. We're actively talking to customers and gathering requirements as to what are the different options that they want to get supported, and SQL Server is definitely something we're considering. So please kind of reach out to us if a managed offering for SQL Server is critical for your need to move to Google Cloud. Last question, also a good one. I have used Google BigQuery before for our global program. Will GCP support automatic translation of LINQ SQL to BigQuery? If not, will this be supported in the future? So we're looking into integrations with BigQuery. Right now we have a connector, but we don't have automatic translation from a SQL query to a BigQuery. But this is definitely a great ask, and we will definitely can look into kind of what it means to support this. So if you can send us more feedback on the scenarios that you have that need this feature, or why would this feature help, that will be a really useful input for our teams to consider. Cool. So those were some really great set of questions. Thank you for listening in, and we really appreciate your time, and hopefully this session has been valuable. Let us know, give us feedback, and we hope to see you in the cloud. Thank you.